This is X-ray protection recording part 2. We're going to first start talking about film speed. And we've talked about film speed a little bit just in different lectures this semester already. But we want to talk about just a little bit more here as far as a safety feature. When they first originally developed film, it started with A speed. And then as they developed faster and faster film, they got up to F speed. And again, nobody really liked it. It was too grainy looking. So E and a half is about as fast as the film ever got. The most commonly used is D or E speed, and that E plus is the E and a half, which is a little, probably the most common, a little more commonly used, because you get the quality and you get the safety feature of having the faster film. And the reason faster film is a safety feature is because it shortens the exposure time that the patient is required to have to sit through. Some other factors, proper darkroom and exposure techniques, and the reason that those are safety features is because if you take the image correctly the first time, you don't have to retake it, because retakes just increase the amount of exposure that the patients have to have. And also proper darkroom technique if you're using film, because if you take an image and it's fine, but then you mess it up in the darkroom by exposing it to light, or having processor chemicals splash on it, or whatever could ruin it in the darkroom, once that happens, you have to retake it, again exposing the patient more to radiation. The film holders just increase accuracy. And if you're increasing the accuracy, you have a better chance of your exposure techniques being correct the first time, so you're eliminating the retakes again. Overexposure and underdevelop is something that you used to see with film. You don't see it as much now, and you definitely don't see it with digital. But what they would do to get the image quicker, they would overexpose the patient, which would typically make the image too dark. And then they would underdevelop it, which typically would make it too light. And so between the darker overexposure and the lighter underdeveloping, they would get an image that was about right, but at the expense of overexposing the patient. Radiation monitoring is just kind of a safety net. You can find out if there are radiation leaks. You can find out if someone's being exposed to too much radiation. A couple of different ways that they can do the radiation monitoring is it can either be a periodic measurement or it can be a continual measurement, meaning that in a periodic measurement they would just measure for a week and see how things go, or maybe they measure for a week once a quarter or something like that. Continued means that either the person's wearing the monitor or there's a monitor in the room that measures all the time. With an area versus a person, you can measure the amount of radiation in an area, say the hallway between radiation units. You can see if there are any radiation leaks that exceed what you would want in the hallway or an area that's near an exposure room. Or the operator can wear a badge that would measure how much radiation they're exposed to. And it's just a difference of whether you want to know how much radiation is present in an area that people could be exposed to, or if you want to know how much radiation an individual operator is being exposed to. There are measurable qualities, and this is how they do the monitoring. Radiation does affect photographic emulsion. That's how it exposes film. It does cause ionization in the air, and that's something that can be measured. It does raise the temperature in the area, and that, again, something that can be measured. And it also causes certain salts to fluoresce or to give off a fluorescent light. And we talked about that characteristic once before when we talked about the intensifying screens. Remember, the X-rays hit those crystals or the phosphors inside the intensifying screens and cause them to give off light to expose your extraoral images. That was your indirect exposure film. Well, this is the same thing, except that there are devices that can measure the amount of light that the salts give off once they're exposed to X-rays. When you talk about an area monitoring situation, that is an on-site survey that's measuring either the output of the X-ray units, or it can be in an area outside of the exposure room, but you're measuring the output, you're measuring an area. The film badges or monitoring badges are the ones that would be worn by a person. They're pretty accurate, they're economical. Some measure just the presence of radiation, and that would be the kind that in a dental office you might wear. There are other types that measure the type of radiation. The type of radiation would be something you'd be more concerned with if you worked in nuclear medicine, where you would be exposed to different types of radiation, and they would need to know what the specific problem was if there was an overexposure. Some monitoring devices, an unexposed film paper clip to your pocket is old school. It just lets you know if you're being exposed to any radiation. And what it does is, because the paper clip is metal, that part of the film covered by the paper clip doesn't get exposed. Everything around it would. So if you process that film and you see the image of the part of the paper clip, you know you were exposed to some radiation. If it's completely blank, then you weren't. A dosimeter, it just measures, it's a meter, it's a measure of the dose of radiation that you were exposed to. Those are a little more specific. And then there are also film badges, which are very common. You see a lot of nurses wearing either dosimeters or film badges. And a thermoluminescent dosimeter almost looks like a really old school fountain pen, and it would clip into your lab coat pocket. That's the type that has the lithium fluoride crystals that would be measuring the light given off by the crystals if it's exposed. Those are a little more expensive. They're a little more specific, and so that might be the type you'd see more in nuclear medicine. I'm not going to ask you these dates, but just to kind of give you a time frame. Remember that X-rays were discovered in 1898, 1895, so pretty quickly they realized that there were problems. By 1902, they were starting to study the effects of radiation on the human body. By 1928, so 30 years after they were discovered, an International Commission on Radiation Protection was founded, and then the next year they established a National Council on Radiation Protection and Measures to set up some standards and set up some safety measures. Again, I'm not going to ask you the dates, I'm just giving you timelines. But they did come up with a radiation protection guide, and under that radiation protection guide, you've got a maximum permissible dose. And you're broken down into two different categories. You're either occupationally exposed or you're non-occupationally exposed, meaning that you're in the general public, and that just means that you're either the patients or someone coming into the operatory. So that would include, occupational is anybody who works in the office and works with radiation. Non-occupational is all of your patients, anybody who works in the office, like in the insurance or front office that doesn't deal with the radiation. Under the occupationally exposed, here are the guidelines that they set up. You've got 50 millisieverts, or 5 rems per year, or 1 millisievert, or 0.1 rems per week. And an easy way to remember that is there's 52 weeks in a year, and they give you 50 millisieverts per year, or 1 millisievert per week, giving you a 2-week vacation. Just an easy way to remember it. The exemptions to occupational, even if you're occupational, you're working in the office, but you're under the age of 18, or any employees who are pregnant, would automatically fall in non-occupationally exposed. And these guidelines for non-occupational is 5 millisieverts, or 0.5 rems per year, 0.5 millisieverts, or 0.05 rems per month. And those are all just numbers you'll have to memorize. There's not a fun way to get around those. Those are just maximum permissible dosages, and you'll have to memorize them.